now here's the problem. So the answer to the pizza question we did last week, and the problem there was what's the probability Jimmy selects two different pizzas, is 72%. And the maths we did for that is up here. There's 3 different pizzas. There's the seafood, the pepperoni, and the cheese. There were 4 cheese, 3 pepperoni, 2 seafood. So we worked out that, and in our sample space we found out the probability of 2 different ones. So that's a seafood and a pepperoni, seafood and cheese, pepperoni seafood, pepperoni cheese, and so forth. And the maths we did, like we all did for homework, is set out here very nicely for criterion C. Okay, the first thing, the probability of 2 different pizzas, that equals the probability of SP, which is the seafood and the pepperoni, plus SC, plus and so forth and so forth. We've worked out the probabilities there, put them down here, and we've finally come up to the answer here. So the probability of picking 2 different pizzas was 52 events out of a total of 72 events. And that's equal to about 72%. Okay, so the mathematics is all there, and it's quite correct. So what we've got here is, that seems a little bit high, that there would be a 72% chance of getting 2 different pizzas. So what I want to do is try and create a model to test if the answer is reasonable. And that's what we did in class today. So one group in class today created a different model. We don't have pizzas in class, so we created a model using these ice cream sticks. So we have 4 cheese pizzas represented here, 3 pepperoni ones, and 2 seafood pizzas. So they were the ones, so we're going to put them into here and pick them out randomly and see if we get the same as we did in the mathematics. So what we need to do now is create a tally chart, and it's going to register how many times the same pizzas were taken out, how many times different pizzas were taken out. And what we are expecting to see is 72% of the time it should be different. So we're going to try and think of a right sample, like a size that we're going to be doing. So we're going to, maybe 10 would be good. So we're going to pull 10 different combinations up and mark them here in our tally graph to see whether we get a very similar answer to that. So the first one, I'm just going to write it down here to make it easier. The same and then different. Okay, first 2 pizzas. We've got a cheese and a pepperoni. So that's different. Put them back in. And again. Seafood and a cheese. Again, different. Put them back in. Pull them out. Pepperoni and cheese, again, different. Put them back in. Pull 2 out at random. Cheese and seafood, again, different. Pick out 2. Cheese and cheese, same. Seafood and cheese, different. Pepperoni cheese, different. So that's 6, 7, 3 more to go. Pepperoni and cheese, different again. next two, seafood and cheese, different again. So we've got 8 there as well. And the last two, pepperoni and pepperoni. And we have 2 there. So our final total is we've got 8 different, 2 the same. And that represents about 80% and 20%. And if we look up to here, it's very similar to what the theoretical probability told us we'll be getting. So we can basically we can draw a conclusion that it is a reasonable answer. We've proved it to be a reasonable answer. Okay, we've done a lot of experiments in class. The first one, they tried it 55 times, and they're getting an answer that's a lot closer than mine. So the idea is the more you test it, the closer you should be getting to the actual number. And that's the case 55 times, 50 times here, 68 times different, which is very, very, very close. Much closer than what I did. I only did it 10 times. Over here, they've done it 55 times here, 22 times here, 50 times here. So that's what we're going to be doing this week.